In this example, the first term of a geometric series is 20. The common ratio is 0.9. For part A, we need to find the value of the fifth term. So first, we start with, we know the first geometric value is 20, so we say A is 20. So if we are trying to find AR, we're told that the ratio is 0.9, so that will be 20 multiplied by the 0.9 ratio. And we know that AR squared, it would be 20 multiplied by 0.9 squared. So since we are asked to find the fifth term, that will be fifth term will equal, in the scenario, AR to the power 4. So that in the scenario would have 20 multiplied by 0.9 to the power 4, which will give us in the scenario 13.122, and this will be our answer for part A. For part B, we need to find the sum of the first 8 terms, giving your answer to one decimal place. So for part B, we have the 8th term. That will be in terms of 20, where we have A, and that will be based on the rule, will be 1, take away the ratio R, to the power of 8, close bracket, divided by 1, take away 0.9, which is the ratio, and that will give us approximately 113.9. This is based on the formula to use. So that will be our answer for part B. And for part C, we are told that given that S infinity is taken away from Sn, that will be smaller than 0.04, where Sn is the sum of the first nth term of the series. So for part C, we need to show that 0.9 to the n is smaller than 0.0002. So for part C, we find S to the infinity, and that will be in the scenario A over 1 take away R. So in this scenario, we have 20 over 1 minus R, which is 0.9, and that will give us 200. So now for us, we'll continue part C here. So what we would have in this scenario, we have S to the infinity taken away from S to the n, and that will be in the scenario 200 taken away from 20 multiplied by 1 minus 0.9 to the n, all divided by 1.0 1 taken away from 0.9, so that will be, and then we'll continue simplifying this expression, so that will give us in this scenario S to the infinity take away from Sn equal 200 minus 20, 1 minus 0.9 n, close bracket, over 0.1. So now for us to simplify this expression, we can get rid of the denominator, so that will give us in the scenario S to the infinity minus S to the n will give us 200 minus, in this scenario 200, we're trying to simplify this fraction, and that will give us 1 minus 0.9 n, close bracket. So now we're moving all the expressions to one side. So what we will do here, we multiply the 200 by the bracket, so that will give us 200 minus 200 plus 200 multiplied by 0.9 n, close bracket. So that will give us in this scenario 200, because these two will disappear, and that will give us 200 multiplied by 0.9 to the n, and hence we're told 200 to the 0.9 n is smaller than 0.4. Then we divide everything by 4. We divide everything by 200, So that will give us 0.9n being equivalent to 0.04 over 200, and in this scenario we would have 0.9 to the n being smaller than 0.0002, and this is what we needed to prove as part of part C. Now for part D, we needed to find that the smallest possible value of n. So since we have 0.9, so we can take the log of both sides. So say log of 0.9 to the n smaller than log of 0.0002. So now we can move the n like this. So the next step will be, because the power moves ahead of the log, so we would have n log 0.9 smaller than log of 0.0002, and in this scenario the n will be the division, because we are dividing, the sign will change, so we'd have log of 0.0002 divided by log of 0.9, and in this scenario that will give us a value of approximately 80.84, and so n minimum will be approximately 81, and in this scenario this is by we flip the sign, so this will be our answer in terms of being approximately 81, and this will be our answer for part D of this question.